Well, my name is G. Venkateshwar Rao, Government Polytechnic, Masattan, Hyderabad, and today's topic is for third year diploma students in electrical and electronics, and topic is protective relays. Well, as before, in the before section we are already studied about air brake circuit breakers, SF6 circuit breakers, and protective relays. So that is protective relays according to duty or application and according to principle and construction. Now in this section we are going to study about the other types of relays, that is relays according to their time of operation, and some of the relays, that is induction, disc type power current relays, and some important terms relating to the relays, and lastly some objective type questions. In the end of the sections you may ask your questions or doubts. Now coming to protective relays, that is the protective relays according to time of operation. For this purpose we can divide the protective relays according to time of operation as like this. First one, instantaneous relay. Second one, definite time lag relay. So in the instantaneous relay, the time of operation, that is these relays are the complete operation of these relays takes place after a short duration. The complete operation takes place after a short duration. These are called instantaneous relays. Next, second type relays are definite time lag relays. In these relays, the time of operation is sensibly independent of the magnitude of the current. So these are the two types of the relays, and other types of the relays are inverse time lag relay, inverse definite minimum time, or simply it called as IDMT lag relay. So in the inverse time lag relay, these relays are also operate, the time of operation is approximately inversely proportional to the current or activating quantity causing operation. And fourth one is inverse definite minimum time lag relay or IDMT relay. In these relays also the time of operation is approximately inversely proportional to the smaller values of the current or activating quantity. Here activating quantity may be current or voltage or power. So in this way, and also in these relays the time of operation is constant after a pickup value, after a larger values of the pickup value. That means the time is constant after the higher values of these relays. So these are the according to time of operation the relays are classified. Now in these relays there are three relays are there. First one is electromagnetic relays, and second one is thermal relay. So in this way we will first study about the thermal relay, how it works and what is its construction and application of the thermal relay. So first one is thermal relay. The thermal relay is like this as shown in the figure. It consists a bimetallic strip. Number 2 is this is the bimetallic strip and is connected between two supports. This is one of the support and this is the other support. This support is the insulation support and this support is the metal support, and another one is element. This is the resistance element. This is the connected to relay. This is the relay element is connected in series with the relay, and this is called element. Here the element is resistance. And third one is the two terminals are there. These two terminals are connected to trip coil. So construction is like this for thermal relay, and operation is like this. Under normal operating conditions, the current flow in the element of the relay coil is not sufficient to heat the bimetallic strip. Whenever a fault occurs on the system, the current flows in this relay is so high, and so the heat produced in this element is so high. Due to this heat production, the bimetallic strip is expanded and touches the two terminals. These are the fixed terminals, and this metallic strip is touching to the two fixed contacts. Thereby the trip coil is closed, and hence it opens the circuit breakers, so that the faulty section is disconnected from the healthy system. Like this the thermal relay works. And coming to its applications, the thermal relays are obsolete because they are replaced by the electromagnetic relays. And other types of relays is electromagnetic relays. In the electromagnetic relays, there are two electromagnetic relays are there. First one is electromagnetic. First one is see the construction of the electromagnetic. This is called as armature. This is electromagnetic armature relay, and it has one electromagnetic. This is the core of the electromagnetic, laminated electromagnetic. This is, and the winding is wound on the electromagnetics. There is so many tappings are there provided here. These tappings are provided for the different current setting, and below the electromagnetic there is one armature is there. This is also laminated one, and it is fixed at one end, and the other end is freely suspended, and here there are pair of springs are attached to this, So in this way the construction of the electromagnetic relay, this is called as armature relay, like this. And coming to its operation, under normal working conditions, the current flow in the electromagnet is not sufficient to attract the armature above. So in this way, under normal conditions the circuit is inoperative, but under fault conditions the current flow in the electromagnetic is sufficient to attract the armature above. So in this way it is excited upward, and the terminals, that is the body of the iron armature, is attached, connected to the fixed terminal of the trip circuit. In this way the trip circuit is closed, and it energizes and opens the circuit breaker contacts. Therefore the faulty section is disconnected from the healthy system. In this way the electromagnetic relays works. This is the armature type electromagnetic relay. Other type of electromagnetic relay is like this, as shown in figure. This is iron plunger electromagnetic relay. There is a coil. This is a cylindrical, hollow cylindrical coil, which where the windings are wounded on this. And second one is, this is called iron plunger, which is moved in the hollow cylindrical coil. This coil is nothing but solenoid, coil also called as solenoid. So this iron plunger is moved in the up and down, moved in the cylindrical coil, and one this is the fixed contacts of the trip circuit. So this is the construction of the solenoid plunger relay. This is also electromagnetic relay. So coming to its operation, under normal working conditions, the current flow in the coil or in the solenoid is not sufficient to pull the iron plunger inside the coil. So in this way it is not operative for under normal working conditions. For abnormal conditions or short circuit conditions, the current flow in the circuit in the coil is sufficient to it attracts the armature plunger inside. So in this way the top of the two contacts are touching the two fixed contacts of the trip coil. Thereby the trip coil is closed, and it opens the circuit breaker. Thereby the circuit breaker disconnects the faulty system from the healthy system. Likewise the electromagnetic relays are useful in the protective relays. So coming to its applications of the electromagnetic relays, these are the applications of the electromagnetic relays. They are used for both AC and DC supplies and as auxiliary relays. So these are used for both AC and DC supplies as well as auxiliary relays. So coming to next one is induction type overcurrent relays. Next one is induction type overcurrent relays. These are also called as non-directional relays. These are works on the principle of induction principle. So induction principle is like this. The interaction of two fluxes that are induced in the disc produces a net force. This net force produces a produces a driving torque on the disc which is in the direction of net force developed. So in this way the relay works according to the principle of induction. So for this purpose these relays are used for protecting purpose, and these relays are operated whenever a current exceeds its pickup value, then the relay operates. These are only used for AC quantities only. These are used for only AC quantities only, and these are can be used for the current flow in either direction. That means to and fro. They are used for the current flow in either direction. So next one is induction type overcurrent relays, non-directional. So construction of the induction type overcurrent relay is like this, as shown in the figure. This is the induction type overcurrent relay. It consists of a C, that is the aluminum disc, which is placed between the two electromagnetics. That is the upper electromagnet. This is the upper electromagnet, and this is the lower electromagnetic. It is placed between the two poles of the two magnets, and the upper electromagnet has two windings. A is primary winding, B is secondary winding, and primary winding is connected to the secondary of the CT. So this is the CT means current transformer. The secondary of the primary winding is connected to the secondary of the CT, and where the CT is connected, the primary of CT is connected to the line. That is the line is the line is protected. That means primary is line and which is protected, and the secondary of CT is connected to the primary winding of the upper electromagnetic, and there is some 1 to 7 tappings are also there. These tappings are brought out and connected to the plug setting bridge. So this is the plug setting bridge. These are the settings, current settings. We can use these current settings for different current values. We can use these relay for different current settings. So like this primary winding is connected, and secondary winding is, this is the secondary winding. This secondary winding is energized by the induction of the primary winding and is connected in series with the lower winding of the lower magnet. So the secondary winding is connected in series with the winding of the lower magnet, and the disc, this is the aluminum disc. This aluminum disc carries a fixed contact. This is the fixed contact. So it carries a fixed contact. The fixed contacts can be set to a preset angle. That means it can be set from 0 to 300 degrees. So in this way the time also set in these relays. That means we can set this fixed contact at some 70 or 90 degrees. So it will travel to the degrees and touches the two fixed contacts of the relay. So this is connected to the trip circuit. That means relay. This is two fixed contacts are there. This is connected to trip coil, and it will travel some distance according to preset angle and touches the two fixed contacts. This is the moving contact. This moving contact moves and touches the fixed contacts. So it will goes to the trip circuit. And there is also spring, spiral spring is provided for restraining torque or controlling torque. For the controlling purpose, there is also a spiral spring also provided here, but it is not seen here. So there is a controlling also there provided by the spring. So this is the construction of the induction type overcurrent relays. Coming to its operation, under normal working conditions, the current flow in the primary winding is not sufficient to produce driving torque on the disc, so that the restraining torque or the controlling torque is greater than the driving torque. Therefore the disc remains in stationary position. So under normal working conditions the disc remains in stationary position, but as well as short circuits or abnormal conditions occurs on the system, then the current flows in the primary winding is such high, or this is also called as operating coil of the relay. So such so high, the current flows in this winding is such so high, this produces torque on this disc. Here torque is nothing but a twisting movement, that means rotational movement. here the driving torque produced here on the disc is more than the restraining or controlling torque of the spring. Therefore, the disc starts to rotates and it rotates the preset angle, then it touches the fixed contacts of the trip circuit, then the trip circuit is closed, then trip circuit is automatically opens the circuit breaker, then the faulty system is disconnected from the healthy system. Like this like this the relays works. So this is the construction and working of these relays. Next, coming to types of induction type overcurrent relays. There are three types of induction type overcurrent relays. They are, first one is definite time overcurrent relay, inverse time overcurrent relay, inverse definite minimum time, that is also called as IDMT overcurrent relay. So coming to first one, definite time overcurrent relay. These relays are operated after a predetermined time when the current in the circuit exceeds to a pickup value. Then the relays comes into picture, and the relays operation comes into picture. In these relays, the activating source is current. So as well as the current increases to the set value, that is predetermined value, then the relay comes into picture and it operates the circuit breaker, and circuit breaker operates the faulty system, disconnects the faulty system from the healthy system. Like this, these relays are working, but in these relays the time delay mechanism is provided. The time delay mechanism is provided by the intentional time delay in the relaying circuit in these relays. That is, the desired time of operation is provided in these relays by providing a intentional time delay mechanism in the relays. Second one is inverse time overcurrent relays. These inverse time overcurrent relays are also operated upon the time of operation. The time of operation is approximately inversely proportional to the operating current. So the desired operating current increases, the time of the relay is decreases. That means inversely proportional to the operating current. Like that, these relays are works. And third one is inverse definite minimum time relays. So these relays are also works on the same principle of inverse time overcurrent relays. That is, the operating time is approximately inversely proportional to the fault current near pickup value, but substantially constant, slightly constant over the pickup values. That means after pickup values the time of operation is constant. That means the up to pickup value the relay is operated according to its principle, but after pickup value the current increases, then the time of operation is constant. Like this, the relays are works. So these are the three types of induction type overcurrent relays, and these are only used for AC quantities only. And coming to applications of the induction type overcurrent relays are like this. Applications of induction type overcurrent relays, non-directional. These relays are used for the protection of feeders, transmission lines, transformers, electrical machines, etc. So these can be used for the purpose protection of the feeders, transmission lines, transformers, electrical machines, etc. Next, coming to some important terms relating to the relays. Some important terms are relating to the relays are, first one is pickup value. So what is the pickup value of the relay? You see in the figure, pickup value. It is the minimum current or voltage in the relay coil at which the relay starts to operate. That is the minimum value. That is the operating quantity is either voltage or current, but it is the minimum value to operate the relay. Above the pickup value or equal to the pickup value, the current flow in the relay is sufficient or equal to pickup value or greater than the pickup value, then the relay starts to operate and disconnects the faulty section with the help of circuit breaker. So this is the pickup value. Next one is reset value. So reset value is like this: the value of current or voltage below which a relay opens its contacts and comes to original position. So once the relay operates, it is remaining in the on position, that is the contacts are closed, so we must open the contacts. So in this way the minimum current or voltage falls below which the contacts are opens and the relay comes into its original position. This is called as reset value. For this purpose a reset button is also there on the relay. We will press the reset button, then the contacts are open and comes into its original position. So this is the reset value. Next one is current setting. Current setting is like this. It is often desirable to adjust the pickup current to any required value and is known as current setting. Pickup current equal to rated secondary current of CT, that is current transformer, into current setting. So in this way we are already seen the induction type overcurrent relays can be set to any current value and also set to any time of operation. So in this way we can change the time of we can change the current setting also in these relays with the help of number of tappings provided on the primary winding of the relay, and these tappings are connected to the plug setting bridge as shown in the figure like this. So this is the current setting of the relay. So these are the number of tappings are coming from primary winding of the relay or operating coil of the relay. These are 1, 2, 3, 4, 5, 6, 7. 7 tappings are there, and these tappings each have a value expressed in the percentage of rated current of the CT. That is the rated current of CT is taken and it is given as percentage of rated current. So this is 50%, this is 75% of rated value, this is 100%, this is 125%, this is 150%, this is 175%, and this is 250%. So normally these relays are range from 50 to 200 in the steps of 25% of the value. So like this we can change the current setting of the relay in this way. Next one is, see the example for for finding the current setting of a relay. There is a problem for you. Problem example: an overcurrent relay having a current setting of 125% is connected to supply circuit through a CT current transformer of ratio 400/5. Find the pickup current. So you must find the pickup current like this. Rated CT secondary current equal to 5 amperes. So here this is the CT ratio. So CT ratio means already you know the transformer ratio. This is the primary turns, this is the secondary. So N2/N1 transformer ratio is given by N2/N1. So this is related to the primary, this is related to the secondary. So that rated CT secondary current is 5 amperes. Therefore the pickup value will be 25% more than 5 amperes. So already said that it is the percentage of full load rated current. So here the rated current is 5%, 5 amperes, and the current setting should be at 125%. So 125% of the 5 amperes we will take. So in this way 5 into 1.25 equal to 6.25 amperes. So this is the pickup value of the relay. That means we set the value, pickup value at 6.25 amperes. So as long as the current below this value, the relay does not operate. But as long as the relay current equal to pickup value, that is 6.25 amperes or more than this value, then the relay operation comes into picture, and this will trips the trip coil circuit and it opens the circuit breaker. Then the circuit breaker isolates the faulty system from the healthy system. Like this the current setting works on the relays. Next one is plug setting multiplier. Simply we call as PSM, plug setting multiplier. It is the ratio of fault current in the relay coil to the pickup current. So this is the ratio, simple ratio, that is fault current to the pickup current. That is PSM equal to fault current in the relay by pickup current Here already you see the pickup current is equal to rated secondary current of current transformer into current setting. Therefore, the PSM plug setting multiplier equal to fault current in the relay divided by rated secondary current of CT into current setting. So, this is the plug setting multiplier. For this also there is one problem for you. A relay is connected to a CT of ratio 400/5 and the relay set at 150% with a primary fault current of 2400 amperes. Find the plug setting multiplier, that is the PSM. We find the PSM like this. The solution is like this. Pickup value equal to rated secondary current of CT into current setting. Rated secondary current is equal to 5 amperes. So, 5 into current setting at 150% into 1.5, that is equal to 7.5%. That means this is the pickup value. As long as the relay comes are equal to this value, then the relay operation comes into picture. Then fault current in the relay coil is 2400 into 5/400, that is equal to 30 amperes. So, this is the fault current of the primary winding of the CT. So, we must change this fault current into secondary winding. So, in this way we take the transformation ratio then convert it into primary fault current into secondary current, that is equal to 30 amperes. This is why, because we are connected to the secondary of the CT. We are connected to the secondary of the CT to the relay coil. That's why we are taking the secondary in terms of secondary current, that is 30 amperes. Here the fault current is 30 amperes in the secondary. Therefore, PSM plug setting multiplier equal to this 30 by pickup value. So, that is equal to 4. So, therefore, the pickup value is 4. For this purpose there is one graph one graph is also for this purpose is there. You see that graph of the plug setting multiplier with respect to the time of operation. First one is the plug setting multiplier is along x axis and time of operation is along y axis. So, as we are already find that we coming the plug setting multiplier is 4. According to this plug setting multiplier, the time of operation is like this. So, exactly off, that is it is between the 6 and 8, that is approximately it is 7.5. That means the for the plug setting multiplier of 4, the time of operation is 7.5 seconds. So, this is not actual operation of the relay, but it is only the actual, it is the time of the operation of the relay. So, this is the one of the plug setting multiplier. Then next one is time setting multiplier. A relay is generally provided with control to adjust the time of operation. This adjustment is known as time setting multiplier. So, in these relays we are also see in the previous figures, these relays are provided with current setting as well as time setting also. In these relays we can provide time of controlling the time of operation also with the help of distance travel of the moving contact of the disc. So, next one is for this purpose we can provide a dial of the time setting. So, the dial of the time setting is like this. It is the dial of the time setting. It is simple multiplier only. It is the range of this is 0 to 1.0 seconds. In between it is divided into 0.2 seconds, 0.2, 0.4, 0.6, 0.8. So, these are the multipliers only. Why? Because this is for the actual operating time of the relay is converted into multiplying this multiplier with the read off value from the PSM time curve. We are already seen PSM time curve. That PSM time curve, the PSM is set at 4 and the time is 7.5. So, the actual time of relay operation is 7.5 into the setting of the multiplier. So the setting here we set at 4.4. So therefore actual time of relay operation is like this. See in the figure. Here according to PSM 4, the time of operation is 7.5. So actual time of the relay is equal to 7.5 into this plug setting, that is 4. 7.5 into 4, that is the actual relay operating time. So what is this? The relay operating time, actual relay operating time is 3 seconds. So the 3 seconds the relay should operate, provided that the relay should cross its pickup value. That means as long it will set two values, the current control is also there, the current setting also there, and there is also time setting. So the current exceeds its pickup value, then at the time of 3 seconds the relay should operate. So like this the relay operates. For this purpose, calculation of relay operating time. To calculate relay operating time, following things must be known. Those are: obtain the time PSM curve, get the current setting, get the time setting, how much the fault current, get the CT ratio. These should be known for calculation of the relay operating time. And procedure for calculating actual operating time of the relay is like this. Convert the fault current into the relay coil current using CT ratio, then calculate the PSM from the time PSM curve of the relay of that particular relay. Read out the time of operation for the above calculated PSM, then determine the actual time of operation by multiplying the above time, that is the read of time of the relay from PSM curve, with time setting multiplier. Then we can get the actual relay operating time. For this purpose there is one problem for you. This problem is like this: determine the time of operation of a 5 ampere 3 seconds over current relay having a current setting of 125% and time multiplier of 0.6 connected to supply circuit through a 400/5 CT ratio when the circuit carries a fault current of 4000 amperes. Use the time PSM curve as shown previously. So for this purpose we will calculate the actual time of the relay like this. CT ratio is equal to 400/5, rated secondary current of CT equal to 5 amperes, then pickup current equal to 5 into 1.25, that is equal to 6.25 amperes, then fault current in relay coil equal to 400 into CT ratio 5/400, that is equal to 50 amperes, then plug setting multiplier PSM equal to 50/6.25, that is equal to 8, PSM equal to 8. Corresponding to the PSM of 8, the time of operation is 4 seconds. You see the PSM time curve, the PSM is where you get 8. So according to this 8 PSM, the operation time is 4 seconds, right? So this is the time of operation is 4 seconds from the time PSM curve. Therefore actual relay operating time equal to 4 into time setting, and the time setting is 0.6. So 4 into 0.6 equal to 2.4 seconds. So the relay is operated after 2.4 seconds when the current exceeds in the relay of the pickup current. So these are the some of the electromagnetic relays and overcurrent relays. So here is some objective type questions are there. You follow this objective type questions. Current chopping mainly occurs in the following circuit breaker. CB is circuit breaker. A. SF6 circuit breaker. B. MOCB minimum oil circuit breaker. C. ABCB air blast circuit breaker. D is BOCB bulk oil circuit breaker. And here the correct answer is ABCB air blast circuit breakers. Then second objective question is, for 220 kV kilovolts electric power line, the CB preferred is SF6 gas circuit breaker. SF6 means sulfur hexafluoride gas circuit breaker, air blast circuit breaker, minimum oil circuit breaker, bulk oil circuit breaker. And the correct answer is ABCB. And next objective question is, in air blast circuit breaker, for breaking the contacts, what type of air is used? So A is dry air is used, B is air at low pressure is used, C is compressed air is used, D is hydrogen gas is used. The correct answer is compressed air is used. Compressed air at 14 kgs for square centimeter or 16 kgs for square centimeter is used. And next objective question is, the arc interruption time is minimum. The arc interruption time is minimum in bulk oil circuit breaker or minimum oil circuit breaker or SF6 circuit breaker or ABCB, that means air blast circuit breaker. The correct answer is D, air blast circuit breaker. And next objective question is, electromagnetic relays are suited for A. AC and DC, B. AC, C. DC, D. None of the above. So here the electromagnetic relays, these electromagnetic relays can be used for AC and DC, but electromagnetic induction type relays are only used for AC quantities. That is the difference between the electromagnetic and electromagnetic induction relays. Next question is, a protective relay should operate for minimum fault. This property is selectivity, A. Selectivity, B. burden, C. reliability, D. sensitivity. The correct answer is D. sensitivity. Next question is, a thermal relay works on A. magnetic effect, B. electromagnetic induction effect, C. heating effect, D. electrostatic effect. The correct answer is heating effect. Thermal relay is on heating effect, works on heating effect. Next question is, a protective relay should not fail to operate in the event of fault. This property is known as A. selectivity, B. sensitivity, C. reliability, D. stability. The correct answer is reliability. And next question is, power consumption of a relay is called A. power, B. energy, C. voltage, D. burden. So the correct answer is power input is in volt amperes and it is called as burden. Power consumption of a relay is called burden. Next question is, bimetallic strip is used in the
Hello?
following relay?
Hello?
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 Will you please tell me how thermal energy works on heating effect?
So you are already see. So the question is how the thermal relay works. Here heat production is proportional to the square of the current. Heat production is proportional to the square of the current. So whenever the current increases, the heat energy also increases. This heat energy, as seen in the thermal relay, directly works upon the bimetallic strip. The bimetallic strip is very sensitive to heat. So in this way, increased current produces more heat. So this heat is transferred to bimetallic strip, and the bimetallic strip is expanded, and it is expanded touches the fixed contacts of the trip relay. Then the trip relay operates and the circuit breaker also operates. So the faulty system is disconnected from the healthy system. But these thermal relays are now obsolete because they are replaced by electromagnetic relays. So the objective question is bimetallic strip is used in the following relay. 1. A is electromagnetic, B is thermal, C is electromagnetic induction, D is none of the above. So the correct answer is bimetallic strip is used in thermal relays. Next objective question is a relay performs the function of A. fault detection, B. fault clearing, C. both A and B, D. none of the above. The correct answer is it only detects fault detection. It is only fault detection, but the relay performs only fault detection. Next question is a 1 volt ampere relay is dash sensitive than a 3 volt ampere relay. The answers are A. more, B. less, C. medium, D. none of the above. The correct answer is more. So 1 volt ampere relay is more sensitive than 3 volt ampere relay. Next question is induction relays can be used for dash quantities only. Induction relays for dash quantities: A. AC, B. DC, C. both A and B, D. none of the above. The correct answer is only for AC quantities induction relays. And next objective question is plug setting and time setting is possible in, this means plug setting is current setting, time setting is time of operation, is possible in A. induction disk relay, B. thermal relay, C. electromagnetic relay, D. moving coil relay. The correct answer is induction disk relay. And next objective question is in induction relay the current setting can be changed by changing the current setting, changing the number of turns in the secondary winding, number of turns in the primary winding, both A and B, D. none of the above. So the answer is number of turns in the primary winding. And next question is in induction relay the time setting can be changed by changing the time setting, connections of the secondary winding, distance of travel of the disc, both A and B, D. none of the above. The correct answer is distance of travel of the disc, distance of the travel of the disc. So these are the some of the objective questions. In the next coming class we will discuss directional type overcurrent relays.